Welcome back to another episode of Who Wants to Be a Mathematician? I'm your host, Mr. Hill, coming at you with some AP Calc review in this annoying little instrument that I happen to find along the way. Alright, so we're going to go through each problem and just figure out what it is. So our first couple problems, we're dealing with limits here. So x squared over x minus 3 minus 9 over x minus 3. Well, the first thing we always try to do when we have a limit is plug in. So let's plug in. So 3 squared over, oh hey, that's a little wrong there. Let's change that around so it actually works the way we want it to. We're actually approaching 2 in case you at home didn't know. So we have 2 squared over 2 minus 3 minus 9 over 2 minus 3, which is equal to 4 over negative 1 minus 9 over negative 1. Well, if I subtract a negative, I get a positive, so those are going to cancel out. It's going to be so similar denominator, so I have negative 4 plus 9, which equals 5. Boom, done, easy. Moving on. Ignore B because B is crazy. We're going to move on to C. So the limit as x approaches infinity of 3x cubed. Yep. Over. Oh, let's finish it all off. What am I doing? X plus 1 do x squared minus 7x cubed plus 1. Well, whenever we deal with different. Hold on. Oh, technical difficulties. Okay. Whenever we deal with limits approaching infinity, so whenever this is infinity, that's important. All we care about is the highest power on top and bottom. So the highest power term is this term. Then we have a sneakily hidden term there. So we have 3x cubed all over negative 7x cubed. Well, the x cubes canceled out. We have negative 3/7. Done. That was pretty easy. Let's move on to the limit as x approaches trace, absolute value of x minus 3 all over x minus 3. First thing we always try to do first is plug in. Well, if we plug in, our denominator is going to be 0, so that's sad face. We don't want to do that. But if you think back to your awesome calculus training, we know that the graph looks something like this, or something like this. And this value here is going to be 3, because that's the limit value that we're approaching. So those values are going to be the same. And the way that we determine is if it's the first case, or the second case is if our x is positive or negative. So we have a positive x, so that means that it's going to be this first case, because when we plug in a negative number, it's actually going to be negative, and when we plug in a positive number, it's actually going to be positive. If I had negative x, when I plugged in a negative number, it would be negative, and when I had a positive x, it would really be negative. So we know that as we approach the limit, that's dealing with left-hand side and right-hand side. Well, obviously our left-hand side and our right-hand side are different. D and E. Limit as x approaches 1 of z squared minus 1 all over root z. And reminds me of root beer. I love root beer, so delicious. First thing we always try to do is plug in. We get 1 minus 1 all over 1 minus 1, 0 over 0. If you get 0 over 0, then you need to simplify. So what that looks like is, well, z squared minus 1 all over root z minus 1. And if we have a root minus a number or a root plus a number, we always think of the conjugate. So z plus 1, root z plus 1. So this turns, our denominator turns into perfect squares. So we have z squared minus 1 times root z plus 1 all over z minus 1. Well, now we look at our numerator. Hey, perfect square. So I have z minus 1, z plus 1, root z plus 1 all over z minus 1. Cancel out, and I'm left with z plus 1 times root z plus 1. And then we plug in, so we get 1 plus 1 times 1 plus 1, which is 2 times 2, which is 4. Yay! Ooh, now they're changing up on us. We got some piecewise functions. So find the limit as x approaches 2 of f of x, which just happens to be, limit as x approaches 2 of, what do we got? 3x plus 2 all over 10x minus 10 minus x, whatever English words are. Here we are. So first we need to talk about left and right hand side. So this is going to be our left hand side because we're less than, and this one's going to be, let's do blue, right hand side because we're greater than. So we plug in 2 and we get 3 times 2 plus 2, which equals 8. And we get 10 minus 2, which equals 8. Left and right hand side agree, so the limit as x approaches 2 of my function equals 8. Boom, ba-doom, ba-doom. And we have limit as x approaches negative 1 of my function is equal to, let me just substitute our function in, negative 1, blah, blah, blah. Am I doing? Yep. 2x plus 2 all over x squared minus 1. Pretend that's an x squared. Just work with me, people. Alright, so now we need to pick our left-hand side. So it happens to be the same. And then we plug in, so we get 2 times negative 1 plus 2, which equals 0. Now we do our right-hand side, so we plug in right-hand side is equal to negative 1 squared minus 1, which happens to equal 0. So left and right-hand side agree. So then I would say the limit as x approaches negative 1 of my function is equal to 0. Ta-da! I did that right. X squared 2 minus, yep. Ooh, continuity. Alright, so we're looking at our function when we have 1 plus absolute value of 4 minus x absolute value, and we have 4x. When x is not equal to 4, and when x is equal to 4, well, if I'm not equal to a value, let's just kind of come over here and look at a little graph here, do a little graph representation. We'll graph this. We know absolute value. We're going to deal with reversing, flipping around, so we're going to look something like this. Up 1 over 4. 1, 2, 3, 4. Up 1, that's where the point is. But, oops. Oh, no, let's undo. And we want an open circle here, because we're not equal to that point. Well, at that point, we're 4x, so at 4, we're 1, 2, 3, 4, 5, 6, 7, 8. So it looks something like this. Just graph that real quick. So the reason why it's over here and not over here is because I have a negative x on the inside, and this reflects it about the y-axis. So if you're confused why that happens, because it's on the inside. Alright, so now that we have our picture, if we're looking at our picture, continuity, like obviously it's not continuous because we have a giant gaping hole right here. Like, yikes, what's going on? So let's talk about how I would know that. I would know that because these things are equal and not less than or greater than signs. If I have something that's equal and not equal, then I graph this whole thing except for at 4. That's why I have a giant hole right here. So I graph this except for the point, and at this point I graph it up here. So let's talk about our left hand and right hand limits. So to show continuity, excuse me, we need to show 1, that the limit as x approaches c exists, and that our second thing, that f of c exists, and the third thing is that f of c is equal to L. So let's find our limit, shall we? Let's take our first one. So right hand side and left hand side all deal with the top function. So the first thing we always do is so limit as x approaches 4 of 1 plus absolute value of 4 minus x is equal to, first thing we always try to do is plug in. So I get 1 plus 0, which is 1. So I know that L is equal to 1, my limit value. Now I need to find my function value. So I'm going to find f of 4, because remember, This is our c value right here, right here. These are all our c values. F of 4, we use our bottom function. 4 times 4 is 16. Did I get... it's supposed to be a 2. Bumper knuckles. Nah, that's supposed to be a 2. I'm sorry. Sorry. Let's just back up a little bit. It's supposed to be a 2x. Yeah, you all thought you'd get me. But I was the one that got you in the end. It's a 2. It's a 2. It's a 2. So I get 8. So now I know that f of c does not equal my limit. So that's to say that 8 does not equal 1. That's supposed to be a 1. 1. Come on. 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 Oh my gosh. There we go. So this is discontinuous. That's it. So let's move on to number 5. I need some water. So we're dealing with find the type of discontinuities by definition. So let's look at our function. F of x is equal to 3x all over 3x squared minus 6x. So we want to name where is discontinuous and find the types by the definition. All right. First thing we're going to do is simplify. So I have 3x on top. I can pull out a 3x out of my denominator to get x minus 2. This turns into 1 over x minus 2. And if I cancel out, that means there's a hole. So I know there's a hole at x equals 0, because you can set 3x equal to 0, x equals 0. And if I have something remaining, I set the denominator, so I have a VA at x is equal to 2, because x minus 2 is equal to 0, so that means x equals 2. So now that I know I have a VA and a hole, now I need to go back to the definition of these things. So the hole, I need to show that the limit as x approaches my c value of my function does not equal my function value. That's it. So what I would do is the value that I'm approaching is 0, so the limit as x approaches 0 of my function value is equal to, well, if I plug in 0, I'm going to get 0 over 0, so that doesn't work, so I have to look on the left and right hand side. So I'm going to plug in a number a little bit bigger than 0, so let's pick, I don't know, 0.001. I'm going to get 0.003 all over, oh man, this is getting crazy. It's going to square, so we're going to get a couple more zeros, minus 0.006, and we get some ridiculous value, right? Yes. So whatever this is, well, this is not going to be what happens as we approach 0. So we know that if I plug in 0, so if I plug in 0 to this thing, now that it's simplified, right, I can use my simplified version, I'm going to get 1 over 0 minus 2, which is equal to negative 1/2. And I know that these two things are not equal, because I have to get something really, really close and half. So I know that I have a whole limit that's using the definition. So let's talk about our VA. Our VA tells us that we have an infinite discontinuity. So that means that I have to show that the limit as x approaches c from the left or the right, doesn't matter, is some type of infinity. And f of c does not exist. So I'm approaching 2 at this point, because our VA is at 2. So the limit as x approaches 2 from the right of my function is equal to, so remember my function is 1 over x minus 2. I'm going to plug in something a little bit bigger. I'm going to get a positive number. So that means I'm going to positive infinity. And if I plug in 2, I get 1 over 0, which is dne. So that's how I would do that one. Oh, the coughs are real. So if my function, let's move on to number 6, is equal to cx squared minus 3 and cx plus 2 if x is less than or equal to 2, or if x is greater than 2. And I want to show that it's continuous. If it's continuous, I need to show that my left-hand side is equal to my right-hand side. So I'm going to figure out my left-hand side. That's going to be equal to c times 2 squared minus 3. And my right-hand side is going to be equal to c times 2 plus 2. So in order for those to happen, I need 4c minus 3 equal to 2c plus 2. Now I just solve for c is equal to 2c plus 5. 2c is equal to 5. c is equal to 5 halves. That's it. I did it. Number 7. We want to state 3 conditions of the function to be continuous at a point. We already kind of did that, but let's remind ourselves. Those are our 3 I's. The first one is that the limit as x approaches c of our function exists, and we're going to call that L, and that our point exists, and that our function value at the point is the limit. So we need to show that f of x, which is 1 over x minus 1, is continuous at c is equal to 3. First thing, limit. So I'm going to say the limit as x approaches 3 of my f of x. First thing I'm going to try to do is plug in is equal to 1 over 3 minus 1, which is equal to 1/2. Yay. And next thing is I'm going to find f of 3, which is equal to 1 over 3 minus 1. Hey, it's the same thing. Look at that. So I say that 1/2 is equal to 1/2, namely that my f of c is equal to my limit, so therefore it's continuous. And we're happy about that. So this is my I, this is my I, and this is my I. So did that. So now moving on to some craziness. Intermediate value theorem. So happy about this. So IVT. So our function is equal to 2x minus x squared on the interval from -1 to 2, and I have w is equal to -1. Well, remember that w is really just f of x. I'm sorry, f of c. So f of c is equal to -1. So step 1, am I continuous? Well, that's a parabola, so yes, I'm continuous. Step 2, I need to find my f of a. So I take my a value, so this is my a value, this is my b value, plug it in, and I get 2 times -1, which is -1 squared, blah, blah, blah. So I have -2 minus 1, which is -3. Then I find my f of b value, so that'd be f of 2, which is equal to 2 times 2 minus 2 squared, which is 4 minus 4, which is 0. And then I have my f of c is equal to -1. So to verify what it asks, to verify, this is important, to verify, we need to show that f of c is in between f of a and f of b. Well, f of a is less than, and f of b is greater than. Now it's not equal to at this point because 3 is not equal to -1 or 0. They're strictly less than. So to verify, I have to show this. I showed this, I'm happy. So now I can say, so by intermediate value theorem, I know there has to be a c value in this interval such that my f of a is less than my f of c, which is less than my f of b. That's what I have to do for part A. So part B says draw it. So if we're going to be all crazy, let's get our axes going here. So first, I'm going to plug in the point a comma f of a. So that's going to be -1 comma -3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So -1, 3 is right here. Now I'm going to plug in my point b comma f of b, which is going to be 2 comma 0. So 1, 2, 0. It's there. I have to draw my function. I know that it's a negative x squared, so I'm going to be down. So I have a downwards parabola. And I know that my function value, f of c, is equal to -1. So I find -1, I find my function value, and there I go. So I'm going to label my points. So this is c. I can just label these points. So this is c, f of c. This is b. This is b, f of b. And this is a, f of a. So I have drawn the graph and connected lines, found the values, and I'm happy. And that's what I got. So have fun, and good luck tomorrow.